Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And today we are gathered here to witness hopefully another lunar landing, and this time from Intuitive Machines from the USA. And yes, this is the part of that program only in which the Astrobotics Peregrine lander did not land. I mean, it was not successful. So this is the part of CLPS program, NASA's CLPS program. We will talk about it, but yeah, today we are going to see something going to the moon. Let me just verify once, last minute verification that it is still on. Yep, it's still on. Okay, so yes guys, so how are you? Hi Wildflower, hi Randhava traders. I hope you all are doing good, and today with the help of this mission, see, this is one of those missions in which I am very hopeful that this is going to make it, because the company was founded in, if I'm not wrong, in 2013, and they have been doing really good, doing all the research and development and whatnot. And I'm hoping that this is the company which will break the curse of USA to return to the moon. Let's hope that is the case. Now before anything else, we can just jump into the the mission itself. We'll talk about all of the things and what all things we need to look out for, and yes, whether this will, what all things are unique about this mission. So let me just go into the mission profile only first of all. So this is a standard mission profile. It's going to the moon, but it's following a standard mission profile. Here you can see the launch will happen, the ascent, stage step, and after the stage step there will be the landing burn for this thing, the boost back burn, the grid fins deploy, and then finally vertical landing on the landing zone 1 for the first stage. The second stage will do the fairing separation and the payload separation. So this is a pretty standard one. We don't see much of a difference over here than a normal mission, but let me tell you that that is not the case. If we go here, yep, okay, it's not written over here. So at T minus 38 minutes, they'll go for a propellant load on the SpaceX Falcon 9. But before that, they will be doing this thing. Approximately 2.5 hours prior to liftoff, which means they have already done this, teams will begin loading the lunar lander with cryogenic methane and oxygen. Well, this is the first time you might be hearing that there is cryogenic fuels being used on a lunar lander. Well, this is the case on Chandrayaan 3 slim lander. That was not the case. They were using the earth storable propellants, mainly like monomethyl hydrazine or other toxic fuels, N2H4 and all those things. But these are things which you can use but are not sustainable in the long run, because in the long run you will have to handle cryogenic fuels. And if this is the part of CLPS program which is actually going to be a predecessor for the Artemis program, it will lay the foundation. So in Artemis, we know we will be handling the cryogenic fuels on the moon by using liquid hydrogen, liquid oxygen. So to handle it on the moon with humans there would be very catastrophic, can be very catastrophic. So to learn how to handle those fuels in the lunar environment, we should send something over there, and this is what it is doing. So this is some brief things about today's mission. We'll have a look at other things also. So this Intuitive Machines, what do they do? What the hell is this company all about, right? So this Intuitive Machines basically is the all access to the moon basically. Here you can see they have this lunar access services, lunar data services, space system and services, orbital services, blah 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 blah. basically they cover all bases when it comes to lunar exploration. And they have you can see in 2013 they were founded, 200 plus employees already they have. And this is their motto, from a napkin to the moon. This is kind of interesting also, because the founders, why is this the motto? Because their founders, once they were having a dinner in one of the restaurants, and one of the founders jot down all the points, all the things that needs to be done for a company, for this kind of company, on a napkin. And now that things which they jotted down on the napkin is becoming a reality. They have a lunar lander on the Falcon 9, and they hopefully it will be landing on the moon, and not on any place on the moon, but the lunar south pole, which is amazing. And yes, it's going to be more closer to the lunar south pole than Chandrayaan 3. So yeah, so it's basically simplifying the lunar access, not only by providing the lunar access in the basis of a lander, but also some data services also. This one, lunar data services, it's like you are going there, but you can do experiments and all, but what about the communication? What about things you want to do over there, right? Lunar data network, how are you able to simplify the communication? How are you able to increase the speed of the communication, which it cannot be real time, but the speed can be increased. Right now it's very less, very less. So it's not even something which it's not usable internet speed, to be honest, when it comes to today's internet. So that is the case. We'll move on to the lunar access services. So what they offer, ride share, you can have a mission to the moon on the ride share mission. It's like a transporter mission for SpaceX, but to the moon. And then they also have a micro nova, which is it can deliver up to 1 kg of science payload. So people who don't have much of money and they just want to do certain science or some experiments on the lunar surface, micro nova is their way. It's kind of an hopper. It's not a proper, it will be used in the lander itself, so it's not going to land by itself. It will be used by the lander, it will be deployed from the lander, and then it will hop on the lunar surface, and it has a range of around 25 kilometers, which is amazing. Yeah, so that is the case. And talking about the lunar data services, here you can see they are simplifying the communication in the deep space network. Here you can see they have all the this is the lunar tracking and telemetry command center, where they have to have their hands on. So they are doing that only. And they will be having a data relay satellites, 5 of their data relay CON, which will utilize rideshare services to place the satellites into a variety of orbits, which is amazing. And then this mission control, well, this mission control, if you are a fan of Star Trek, it might look familiar, because they have replicated that theme, that bridge here. So, and this control center can be used by other companies as well when they are running their experiments or doing other things. So yeah, that is the case. And now let's move on to today's mission only, which is the IM-1 mission, which is amazing. So we will see this, don't worry about it. Okay, they are actually streaming this. No, okay. All right, no worries. So we'll see this what this IM-1 is all about. This is how the lander would look like. They have the solar panels over here, and solar panels over here also, solar panels over this side also. Basically, but this is the main solar panel which is going to generate most of the wattage, and this is where it is going to face the sun. this is the sun pointing mode. If the sun is kept over here above it, it will be facing that, because this is very necessary in case of this lunar lander, because they have to do thermal management of this lander. They are using cryogenic fuels. They can't just mess around with the fuels with the sun doing that what should I say, what is that maneuver, barbecue maneuver, right? In which it will heat it from all of the sides. But they can do that, but it's not good for long usage, because again it will heat up the tank somehow. It will be even heating on all of the sides, and it will cause the fuel boil off on all those things, which you don't want with cryogenic fuel. You don't want your fuel to go off in middle of the flight, right? So that is the case. So basically what it will do, if the sun is kept over here, it will point to the sun, and this solar panel will take all the beating from the sun. So it will point to the sun with the help of this solar panel. So not only it will recharge its batteries and all those things, but will also prevent the fuel tanks which is kept inside to not get too warm when it comes to traveling in space. So and when it's not pointing directly to the sun, then these solar panels will come into the picture and do the things. They are carrying certain these equipments, which we will see. Let me just move on to the next part. So this is how it will look like. It looks like right now on the Falcon 9 here. It is having landing legs, and it's not squished, or it's not it is right now in deployed state only. And we'll see that you can see basically this, why this mission is known as NOVA-C. C is, if you have studied maths in your school, you might be knowing C stands for, in Roman numerals, 100, right? NOVA-C means Nova 100, and 100 means 100 kilograms to the lunar surface. That's what it is doing. It is capable of carrying 100 kilograms to the lunar surface. Not capable, it is carrying. It is carrying 100 kilograms to the lunar surface. That is why it is NOVA-C. And it's the name of this mission, or is this, it's not exactly a NOVA-C, but it is Odysseus, or Odie, ODIE, nicknamed Odie, right? Inspired by the Greek poem, the Iliad. So that is the case. And so it will land on one of the Malapert A crater, which is around 300 kilometers from the actual lunar south pole. So it's not that far. Chandrayaan 3 was around 600 kilometers. So that is the case. And the mission life of this mission is going to be 7 days, not 14 days, 7 days, because that is how it is made. After 7 days, the lunar night will come, and you know what happened with Chandrayaan 3. When lunar night comes, it's not, no matter what you do, it's very, very rare that if you don't have some sort of RTGs with you, you will survive the lunar night. So that is the case. Okay. Yeah, good luck. All the best, Depratim, for your exams. Hope you make it today. Odie is also the dog in the Garfield comics. Okay, I didn't know about that. I have watched Garfield, but not the comics. So that's a good information. Okay, let's now see the components of this lander. It's kind of a simple lunar lander, and this is powered by, as I said, cryogenic fuels. And this cryogenic fuels is not liquid hydrogen, liquid oxygen, but liquid methane and liquid oxygen, because again, if they are going with hydrogen oxygen, they can go with that. It will increase the size of the lander, it will increase the overall weight of the lander and all those things, and so it won't make much sense to have that as a precursor to actual learning of handling those cryofuels. So we have these it is the liquid methane and oxygen tanks hiding inside these two, hiding inside the container, you can say. Then the solar array is there, the composite helium tank, which is going to pressurize the tanks. So, and again, this will have certain modes. The RCS thrusters will, this is the reaction control system, and these RCS thrusters will be helping to point it to certain modes, which is the solar pointing mode, propulsion vector, and communication. So all these modes, the solar pointing mode is nothing but, as I said, it will point directly to the sun. Then we have the propulsion vector, which means where it has to go, it will point to that particular vector, and then it will start the engines. Then we have the communication mode, in which it will point its high gain antenna directly to the earth, and earth will be able to it will be able to communicate with earth. So it does not have, you know, what should I say, a proper communication to the earth, direct proper communication to the earth. It will have some sort of heartbeat, or, you know, very mission critical data which is sending to the earth, but actual proper data is sent to the earth when it is pointing to in the communication mode. So that is the case. Then we have it's using the 3D printed engine. The heat shield is also here, the aluminium crush core legs. So you might be wondering, why does it have a heat shield over here, right? It's not re-entering the atmosphere and all those things. Well, again, it all comes down to the cryogenic fuels. So you don't want any of the heat which is coming out of the engine to go up and mess up your cryo tanks. So you are having your heat shields over here. And one more thing is that the lunar soil is also very, very, what should I say, infrared radiative. So it's radiating heat all of the time. So if you are at the lunar surface, then it's radiating heat and it's going to your tanks. You don't want that. So you want some sort of protection over here. That's why we have a heat shield over here. So finally we have a navigation pod, and yeah, so this is the case. Let's move on to the next thing, which is the payloads. So first payload is from the NASA. All these are the NASA payloads, which is known as ROLSS. This is nothing but radio observation of the lunar surface photoelectron sheath, which is nothing but it's kind of how it will study how the interaction with the lunar dust occurs. So so basically what it will do is the moon does not have the benefit of the atmosphere to protect its surface, so nothing stops the radiation from hitting it. So the interaction of the radiation with the lunar dust, which needs consideration when you are talking about Artemis mission and all those things. So you need to know how well how are those radiation hitting the lunar surface, how is it interacting with it. You need to study about it. So this experiment is going to study that, and it will not only measure the radio waves from like the sun, but also from the Jupiter, also from deep space, even from the earth itself. So that is the case, and this small looking cute thing, a cute little experiment, weighs around 13 kgs. Okay, now fine. Other part is the obviously the lunar, the all lunar retro reflector array, right? The LRA, and NASA loves to put this on every mission. Chandrayaan 3 has this lunar retro, this LRA reflector array. It had this thing not because India wanted NASA's help, but because NASA kind of, if you want to utilize the NASA's deep space network, you need to have some sort of their scientific equipment, instrument in your spacecraft. So that's why Chandrayaan 3 also has the LRA, but it also has its own advantage. So today, this is not the case with this though. the LRA has a proper purpose. So this is going to be a marker on the lunar surface when so it's going to land near the proposed site of the Artemis mission. So once it is kept over there, then it will help the future missions to properly have the altitude reading with the help of this LRA. So it's kind of a marker on the lunar surface so that you can easily navigate on the lunar surface and land on it. So that is the case. So next one is the NDL, which is developed by Langley Research Center, which is nothing but a navigation Doppler LiDAR for precise velocity and range sensing. So this is nothing but a LiDAR. It is a laser sensing altitude meter. So it's kind of it will emit the light from the radar. It will hit the surface, come back, and it will be able to measure the distance between the surface. So that is the case. Then we have the SCLPS, which is again developed by Langley Research Center. This is the stereo cameras for the lunar plume surface studies. Interesting, right? This device points at improving the safety of future landers during the last instance of the descent. So it will utilize 4 cameras to record footage of NOVA-C engine exhaust interacting with lunar regolith. How cool would that be? So it's actually a camera only, but it will going to record how the interaction of the lunar plume, the engine plume with the lunar surface, and how it is going to change so that basically we want to understand how it is interacting, so that in future missions we can be well prepared. That is the case here. So I am hoping we will be getting some good images in future. Then we have the LN-1. This is the developed by Marshall Space Flight Center. This is nothing but Lunar Node 1 navigation demonstrator. So it's like a device. This device should help to guide spacecraft arriving or leaving the moon by using S-band radio waves. So demonstrator will only emit signal that NASA's deep space network will use to obtain precise positioning. So it's kind of a navigation control, navigation sensor only. That is the case. Then we have the commercial payloads. The first commercial payload is from the Columbia Sportswear. Kind of interesting, right? So Columbia Sportswear is using Omni Heat Infinity. That is their product, an innovative material developed by Columbia, which is showing great thermal protection. So it's literally that Omni Heat Infinity is being used in this spacecraft as a thermal protector. So it is going to as you know, it's going to store those cryofuels, so it needs to have that thermal protection. And here, this is the sheet which it is going to be covered with, and it's going to protect the spacecraft. Literally, sportswear company providing these kind of solutions. It's very interesting when you see, right? Usually it's the reverse. Things which are developed in space is used in real life. Somehow the applications come out to be, and then here it's kind of reverse. Things which was used for something else is now being used in space. Amazing. Now next thing, which is this one, and this is nice. So this is the Embry-Riddle Eagle Cam, and it's a camera, but it's going to record for the first time third person point of view of landing. So this camera will be deployed around 30 meters above the surface, and it will go down and with the spacecraft also, and it will try to record the, if the spacecraft is going like this, the camera will also go like this, and it will try to record a third person POV of landing on the lunar surface. How cool would that be? This mission, if it is successful, we will be getting some great images, great videos, and I am all for that. So it is also testing an electrostatic dust removal system. So because it will be going to the surface, right, landed on the surface, so why not do some experiments over it? So we need, the lunar dust is the major threat in the moon, on the moon, so we need some sort of removal practices. Here you go, electrostatic dust removal. Plan to orient it to cache. It does not have that capability, Wildflower. So it does not have a orientation capability, but it has the cameras placed strategically. No matter in which orientation it lands, it should be able to get some picture of the lander. So that is the case. Then we have Jeff Koons, the moon phases, the art. So 125 miniature steel moon phases sculptures will fly on the side of Odysseus, later to be displayed on our natural satellite. So moon phases, how it is on from the Earth, those moon phases are there on these steel balls, and it is placed on the side of the moon. And yes, the names of the individuals who achieved a variety of accomplishment in various fields are inscribed in front of each art piece. How cool is that? Now next part is again this is also an interesting one, the ILO-X, which is nothing but International Lunar Observatory Association. So this is kind of a telescope on the lunar surface. This is going to observe the galaxy, the space from the lunar surface, which has never been done before. So it has two cameras, small cameras, which will fly, and the main goal is to take the first images of the center of the galaxy from the moon. How cool would that look like? This mission is going to be kind of a mission which will spark interest from the lunar surface. It's already sparking interest, but this will be a major boost, and I am all for it. This is going to be amazing. Then we have one more thing, which is the Galactic Legacy Labs Luna Prize. This is nothing but it is a collection of messages called Lunagrams, and it will kind of it will preserve the human knowledge for eternity. It is having all those human knowledge inscribed over it, and it's going to the moon, and it will be there. And if something happens to the Earth, I know moon will not be there if the Earth is gone, but still somehow someday some aliens lands on the moon when the moon is drifting as a rogue planet, rogue something. It finds this thing, and it will know that life is there. So yeah, and one more interesting thing is there is something called the Lone Star Data Holdings, which is going to place their one of the kind data center on the moon. Yes, the one this company is basically established to make a data center on the moon. How cool that is. Their main this payload will demonstrate the disaster recovery as a service. So if you have very 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 important data, like big companies, Google, Coca-Cola formula and all those things, right? You want to store it somewhere which it is safe from all of the things right now on here on Earth, because anything can happen. If a nuclear war is down, if we are in a nuclear war, no data center, nothing will protect, right? So to store your data safely, you can store it on the moon, you can store it there, and there no wars, nothing as of now is going to happen. So disaster recovery as a service is being provided on the moon. How cool is that? So yeah, there we have it. That is all we have. And yes, kind of, yes, because if we have a data right now, they don't have the processing capability, but yes, once you have a data center over there, then you can host certain things which is meant to be used on the lunar surface, right? When you have a proper community over there, then you don't have to worry. And if you are, you know, loading your servers, your web pages, your something, all things can be served via that data center, and not you are contacting the earth every time. So it's good, and it's innovative, and let's see how well it pans out. So now all the instruments and all those scientific instruments, so you can see the placements over here, the ILOX, the LN1, the WFOV, which is nothing but wide field of view camera. Here the ILOX is the it will take the pictures of the center of galaxies. The ROLS is antenna, the NASA payload, the scalps cameras, the NDL sensor, all those things are here, and you can see the placement of it. Now moving on, which is the most important thing, the success criteria, and how basically the mission profile would look like. So first the launch will happen, the launch vehicle separation, the autonomous commissioning. So this autonomous commissioning is also very interesting, because this literally means autonomous commissioning. So you don't have to do anything from your end. It will do all the checks, it will wake up the necessary systems, it will charge its batteries. Once it is all healthy, everything is fine, it will then communicate with the earth, and hence it will take some time for it to come alive, kind of, and then it will start communicating with the earth, and you know, do all those things. Then we have the engine commissioning. Engine commissioning is also kind of, it's not auto, but it's directed from the earth. They on their press kit, actually they have mentioned all the steps which they take for engine commissioning, autonomous commissioning, trajectory course maneuvers, and all those things. So you can read about it. It's very in-depth, very interesting, can be understood by a layman also. So amazing. Then we have engine commissioning, we have TCM, which is trajectory correction maneuvers 1, 2 and 3 over here. Then the maneuver to lunar orbit insertion, which is over here, and then finally lunar orbit insertion over here, the low lunar orbit over here, and then finally after that you transit from that to a descent orbit insertion, which is basically in the lunar orbit it will be here there in by 100 by 100 kilometers, and then the descent orbit insertion will happen. Finally the terrain relative navigation will happen. The power descent initiation will start at this point. This is all autonomous. Once it is inside in the lunar orbit, just after an hour it will automatically start landing. Literally it is that. So that is amazing. Then the pitch over will happen at this point with main engine, hazard detection and avoidance here, vertical descent, terminal descent, and then finally the landing will happen. So this is a basic mission profile, which kind of what all lunar landers are following nowadays. So this is how it would look like. Moving on, I wanted to talk about the commercial lunar payload services, but we already know. So this is the part of CLPS, and Astrobotics Peregrine lunar lander was also a part of it. Firefly is also a part of it. Rocket Lab is also a part of it. It's kind of how, with the help of public-private partnership, you are exploring the moon. Now I wanted to let you know where it is landing on the lunar south pole. This image is taken from Jatan.space. Just check out his blog. He writes very good blogs on the lunar moon Mondays, basically he has. So check out his blog. So here you can see Chandrayaan 2 and Chandrayaan 3. This is where they landed actually. Chandrayaan 2 was a bit closer. Chandrayaan 3 is landed over here. And today, I mean, hopefully on Feb 22, the NOVA-C lander is going to land somewhere over here. Much more rocky, much more to the intended landing site, and much more difficult. So it is going to be a very difficult ride, kind of over here only, you know. So this is around 80 degrees south it will land. So we'll have to see. how this all comes out, there will be the Malapert crater over here only, and it will be landing near that, so it will amazing. And then finally, this is what I was talking about, their press kit. You can download it from their website. It has, we have covered all those things, so you don't have to worry about it. But if you want to get much more in-depth details about how things works, this is what I was talking about. You can read about it, you will get some much more knowledge, and they have written in a good detail what they are doing over there. So that is the thing. I just want you to see some interesting facts. Yeah, this is the thing. So Nova Control was designed to resemble Star Trek's USS Enterprise bridge. This is what I was talking about. It uses 2 types of radios, and the science data radios go 16,000 times faster. The first radio is around 1976 modem, and more than 1 mile of cables are installed in Nova-C. And okay, yeah, see, this is also the thing. Nova-C propagates its estimation of position, velocity and attitude roughly 5 times faster than a human eye blinks. So that is the case, and today we have 10% violation of weather probability of violating weather constraints. So that means 90% go for the launch, nothing else. So that is also fine. Now I think that should be it. Let me see if we have the live stream. Yep, just a second.
And control our lunar lander during its journey to the moon's South Pole region. Here's a closer look at how we'll get there. The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic NOVA-C class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2, starting with separation for the launch vehicle on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7 days later, like an outfielder stretching out to grab it.
The first 4 days are dedicated to flight controllers in Houston firing the lander's 3D printed liquid methane and liquid oxygen engine to make small course adjustments to hit its orbit target around the moon. This particular coordinate system is called the B-plane.
You can think about the B-plane kind of like the backboard of a basketball ball. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B-plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side. This critical burn maneuver is completed in the blind, with the moon blocking direct communications back to Nova Control in Houston.
Once we get around the moon, we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other. Then we plunge into night, and now we're cold on both sides. It's very tough.
About an hour before landing, flight controllers command Descent Orbit Insertion, or DOI. This is a main engine firing to slow the spacecraft so its altitude drops from 100 kilometers to about 10 kilometers above the lunar surface. After DOI, Odysseus coasts for about an hour before starting its final approach.
And then we reach a point called power descent initiation. The guidance system on board makes the decision to activate the main engine at very close to full power.
Cameras and lasers are feeding information to the lander's navigation algorithms, which provide guidance, navigation, and control. With a safe site identified, Odysseus enters a 3 meter per second descent, then down to 1 meter per second for the last 10 meters to the lunar surface. Now, the lander is using an inertial measurement unit, which is similar to a human inner ear that senses rotation and acceleration. Flight controllers expect about a 15-second delay before confirming the ultimate milestone, softly landing on the surface of the moon.
And I can tell you just from doing our simulations, that's the longest 15 seconds you'll ever experience as you wait for the final light to turn green to indicate that you've landed on the moon.
Great, great, great.
And that overview of the IM-1 mission was provided by our co-founder and chief technology officer, Dr. Tim Crane, who's also the mission director on our Blue team, which is scheduled for landing operations. Right now, former NASA astronaut and Intuitive Machines' vice president of production and operations, Jack Fisher, is in the mission director's seat. His team is gearing up for launch from Kennedy Space Center, where Megan is standing by with more on NASA's role in the IM-1 mission. Megan?
Thank you, Josh. So you've heard us mention CLPS, or the Commercial Lunar Payload Services Initiative, but what is this new initiative? Well, NASA is teaming up with several American companies to deliver science and technology to the lunar surface. It will streamline the science in studying the moon, but also help us all understand the risks and rewards before human missions to the lunar surface and beyond.
Where's the captain's chair? That is a good question to be asked from them. To be honest, yes, captain's chair is needed, right, to direct everyone. But I don't think so. They have a captain right now. They will have a mission director, but will he sit over there? Not sure. So that is the case. So right now, guys, we are T-minus 30 minutes from the launch. This is the NASA's Viper rover. This is also going to be launched soon to the lunar South Pole, and that is the main rover which is going to actually get to the core of the water. It will, if the most probability of finding actual water with the help of this thing will be with the Viper only, because it will drill down and get for the do the science on the moon only. So yes, 360 degrees swivel chair. So finally, guys, T-minus 30 minutes, around T-minus 30 minutes from the launch. And as I said, this mission is going to be an interesting one, as they are going, hopefully, this is the one which is going to break the curse of the USA to go to the moon again. And hopefully we will see this becoming successful. Today it's going to be launched. All the fuel for the cryo fuels which it is going to have has been already fully fueled, and now it's going to be launched. And yes, SpaceX had to do certain adjustment and changes in the Falcon 9 and the way it works because of the handling of cryo fuels in the payload fairing. Interesting fact.
Technology to the moon. So over the following 4 years, Intuitive Machines has built an entire space program to support these CLPS missions. The company completed its lunar lander in a new facility at the Houston Spaceport, just down the street from NASA's Johnson Space Center. Joining me on set now is Steve Altemus. He is the CEO of Intuitive Machines and former Deputy Director of Johnson Space Center. Good morning to you.
Good morning, Megan.
Let's take a look at this clock. You've been looking at it for quite a while now. So we are 28 minutes from launch. How are you feeling?
I'm ecstatic to be here. Such a historic moment as we get ready to fire the Falcon 9 up and light the engines. All systems are go. The tanks on the lander are loaded, and we're just waiting for this last 28 minutes to light the candle.
So why did you start a company to commercially build and fly lunar landers?
Well, we started a company just because, at the time NASA was thinking about a capabilities-driven framework and no real destination. And so I decided to retire early and think about a business where I could apply human spaceflight expertise in engineering and methodologies to in solving intractable problems around the world in oil and gas and energy, medicine, and aerospace. Well, in 2018, when the National Security Council came up with Strategic Directive 1, which was to say that the moon is now of strategic interest, we turned our whole company towards attempting to land on the moon, to return the United States to the moon for the first time in 52 years.
So we've been talking about your lander, obviously NOVA-C, and your fellow co-founder, Dr. Tim Crane, mentioned that your core group had worked on Project Morpheus, and we have some video to show folks right now. I remember that experimental prototype and the propulsion tests were completed right here at KSC. So how did Morpheus inform what you ended up doing with IM-1?
Well, Morpheus was a terrestrial test bed that was a liquid oxygen, liquid methane lander that actually we flew 37 times, and we learned about how to ignite and to fly a liquid oxygen, liquid methane engine. That core technology is the core technology of our NOVA-C lander. In addition, the autonomous landing and hazard avoidance technology on board Morpheus, while it was older technology, those algorithms are the same kinds of algorithms we use for our hazard detection and avoidance, which is what we do on the moon to land on a place as rocky and craggy as the South Pole. And so we use that technology also, which is a derivative of what NASA produced, but we had in our know-how as we started the company.
And so you're talking about landing. You know, there have been a number of attempts to land on the moon recently, you know, by companies and other countries. Roughly half has succeeded, half have failed. So what has your company done to increase the chances of landing on the moon?
Well, I think first and foremost, what you have to do is you have to be humble about it, and you have to learn from and stand on the shoulders of all those who have gone before. So we looked really hard at every mission that has gone to the moon, and we looked for what mistakes or things in their design that caused their errors, and did those mistakes or did those design deficiencies, are they in our lander? And so we learned from others, and so we appreciate everyone who's tried to go before. But in addition, we bring things together quickly. We bring hardware and software together in the early stages of development testing and test often. And we put them on multiple test beds and test like we fly. And that's the key to success, and that's what I think we did. We learned from human spaceflight engineering to take the best of what we had and what we were doing and then streamline it to be agile and efficient. And we were working on a fixed price budget, so it was essential that we innovated. And I think over-constrained budget, over-constrained schedule, and an incredibly challenging thing like landing on the moon forced us to innovate.
Sure.
And that's the key.
Thank you so much. I appreciate it, and good luck tonight.
All right, thank you.
All right, so once the NOVA-C lander gets to the moon, there are 6 instruments on board that will play a key role in navigating and studying the lunar surface. And the first one is this. It's a lightweight laser retroreflector array, or LRA. This passive optical instrument is a collection of 8, as you can see here, about half-inch reflectors or mirrors used for measuring distance. So the plan is, after NOVA-C lands on the moon, future landers or spacecraft flying near NOVA-C's lunar location can cast a laser towards the surface, and these retroreflectors will bounce the light back to the approaching craft. That reflected laser light will help determine how close the spacecraft are to the lunar surface, ensuring a smoother landing. So really, it's similar to when you're reversing your car and watching a camera to let you know just how close you are to an object.
Yep. It's kind of a marker on the lunar surface. Yes, Ritik did that.
So let's go back now to Houston, where Josh Marshall is standing by live at Intuitive Machines with an update. And Josh, what is the latest?
Thanks, Megan. And if you're just joining us at home, welcome to Nova Control in Houston, Texas. Right now, flight controllers are monitoring launch pad activity and staying in communication with SpaceX's launch control in Florida, where we have another team working side by side with SpaceX to monitor NOVA-C's fueling and launch readiness. After launch, flight controllers working each of Nova Control's 12 positions will prepare for first contact with our NOVA-C class lunar lander. That process
This is amazing. This looks great. The control center, how, you know, circular it is.
Stage, which is scheduled for about 48 minutes after liftoff. After separation, our lander's orbit is called trans-lunar orbit. This enables NOVA-C to reach lunar orbit in about a week, but requires a lunar lander with a very capable engine. NOVA-C was tailor-made for NASA's CLPS initiative and supporting commercial lunar exploration. It's a pillar of Intuitive Machines' lunar access services, and we took a deep dive into what makes NOVA-C qualified for this historic undertaking.
The NOVA-C was our version of a liquid oxygen, liquid methane lander, and we went about imagining that into existence.
And one more interesting fact which I forgot to tell you about is the foot of this lunar lander is inscribed with all the 200 employees' names. So once it lands on the lunar surface, the names of all the people who designed it, who worked with on the NOVA-C, will be inscribed on the surface of the moon. How cool is that? This is something, you know, which some good companies only think about, which actually cares about their employees. So this is amazing. This is something which is great, to be honest.
NOVA-C's structure is primarily carbon composite.
We needed to build the lightest weight structure we could. That meant honeycomb aluminum core with composite face sheets, composite struts, and most importantly, linerless composite propellant tank. Man, what a challenge that was.
Between the engine, carbon composites, software, and electronics required to build a NOVA-C lunar lander, it took an incredible amount of touch labor to get to the launch pad.
We worked very closely with San Jacinto Community College to create a certification course for technicians, where they would take these certifications. We then, in Intuitive Machines, would give them an internship and test them out in the workplace. And anyone that showed the aptitude to be a really good technician, we hired on the spot.
Nearly all of the lunar lander's payloads are mounted to its exterior, including 6 NASA-provided payloads that will help lay the foundation for Artemis missions. Embry-Riddle Aeronautical University's EagleCam, designed to deploy off NOVA-C right before landing to take third-person perspective images. The International Lunar Observatory Association's camera system, mounted at exact angles that could capture images of the Milky Way from the lunar surface. A data center technology demonstration by Lone Star Data Holdings, and Omni Heat Infinity, Columbia Sportswear's thermal reflective insulation used in many of their outdoor products, will help protect NOVA-C from extreme temperatures in space.
They've got brilliant ideas, and if we can help facilitate those startups to help build this economy, I think that raises all boats. And it's as serving as the transportation leg to the moon, we're happy to accommodate those kinds of companies.
Wow, amazing.
The IM-1 landing site is called Malapert A. It's named after 17th century Belgian astronomer Charles Malapert and is expectedly made of lunar highland material, similar to the material studied during Apollo 16, which was also launched from Launch Complex 39A, where we have more from Megan. Megan.
All right, thanks, Josh. And actually, not far from the Malapert A landing site is the Malapert Massif region, and that is one of the 13 candidate regions being considered for the Artemis 3 landing. Okay, so a second NASA instrument on board the NOVA-C lander is NASA's Radio Frequency Mass Gauge, or RFMG. The instrument is essentially a fuel gauge to estimate the amount of propellant in spacecraft tanks in specifically a low-gravity space environment. So during this mission, RFMG will estimate the amount of propellants in NOVA-C's tanks. Once proven, RFMG technology would demonstrate significantly more accurate measurements of a fuel tank's fill level without requiring a thrust to provide a force upon the fuel in order to measure it, as current technology does. For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. To get there, SpaceX and NASA teamed up to develop the human landing system. Here's a closer look at your Artemis Moon Minute.
With Artemis 3 planning to return humans to the moon for the first time since 1972, NASA and its commercial partners continue to develop the systems needed to land crews safely on the lunar surface. SpaceX will provide and operate a moon lander for NASA's Artemis 3 mission called Starship Human Landing System, or HLS. During Artemis 3, NASA's Space Launch System rocket will launch 4 astronauts aboard the Orion spacecraft for their multi-day journey to lunar orbit. The Starship HLS, powered by 2 variants of SpaceX's Raptor engines, will launch uncrewed on a super heavy booster to lunar orbit to pick up the crew. Once on board the HLS, 2 crew members will head to the surface of the moon, where they will live and work for about a week, collecting samples and performing science experiments. Once they're done, they'll get back into Starship to the orbiting Orion and return to Earth. That's your Artemis Moon Minute.
For more on SpaceX's Starship Human Landing System, let's go back to Jesse Anderson live at SpaceX headquarters in Hawthorne, California. Jesse.
Great. Thank you, Megan. Down at Starbase, Texas, we're continuing to build, test, and fly Starship, the world's most powerful launch vehicle ever developed. A fully reusable Starship is capable of carrying up to 150 metric tons to orbit and up to 100 passengers. We completed 2 test flights last year, and 2024 is lining up to see even more Starships take flight. We're still in the testing phase, but major milestones like flying at a high cadence, full system reuse, and on-orbit refilling are key priorities. Refilling on orbit will enable the transport of up to 100 tons all the way to Mars. Down at Starbase, we're gearing up for Flight 3 of Starship. We have a fully stacked vehicle on the pad for the first time since Flight 2 in November of last year, ready to go through pre-launch testing to get ready to fly. We're also building a second Starbase launch tower to further increase Starship's flight opportunities. Also in testing, our engineers are proving out all systems necessary to make a trip to the moon possible, such as propulsion, life support, and even the elevator that you see here, which will take crew and cargo from the Starship hatch opening down to the lunar surface. In partnership with NASA, SpaceX's Starship Human Landing System, or HLS, will put the first Artemis astronauts on the moon. We are part of the global team, which includes Intuitive Machines, that will further exploration of the moon under the Artemis program. SpaceX will perform 1 uncrewed demonstration flight before the Artemis 3 mission, which will be the first human surface expedition since 1972. To that end, SpaceX has been hard at work getting Starship ready for its moon missions and ultimately Mars.
Well, that was a good Starship advertisement, right? Well, it is well deserved, to be honest.
Machines get to play a vital role in that. For those of you who have just joined, we're just about 15 minutes from launch of the IM-1 mission. Let's check back in with Josh at Intuitive Machines. Josh?
See, look at their, you know, guys, look at his dress. It's literally inspired from Star Trek's USS Enterprise, right? Literally, their dress is also kind of same. Amazing, amazing, amazing. I really like it when startups are so open for all these things.
Years at NASA's Johnson Space Center used to integrate technologies for future spacecraft that could land on a variety of destinations in our solar system. The project integrated NASA's autonomous landing and hazard avoidance technology designed to enable a spacecraft to identify, descend, and find a safe landing site that is relatively flat and free of large boulders, rocks, and craters. In the video on your screen, you can see that signature blue fire synonymous with liquid methane and liquid oxygen engines. That's the same fuel used on Nova-C. From December 2013 to December 2014, Morpheus completed 13 free flight tests at the north end of Kennedy's shuttle and landing facility.
This is the
joining
reason.
me now is our co-founder and chief technology officer, Dr. Tim.
This is the reason why I feel this is going to succeed, because they have done their homework properly.
You were working on other things at Johnson Space Center to include Project Morpheus. What can you tell me about Project Morpheus and how that foundings of technology led to us getting to the launch pad today with your company?
Well, one thing I can tell you is I get chills watching that footage because it takes me right back. But this is a journey that clearly our prop technology was a big part of Morpheus we brought forward. Also the all-hat, the autonomous landing, hazard avoidance task, a lot of our navigation, the way we do software, the way we test our systems, and even the discipline about knowing when some technology needs to wait for a future date so we can get to flight. All of that came from the Morpheus experience.
And, you know, just about a year ago, you got to see those Project Morpheus tanks again, but this time they were in your facility and you were testing them with your company. What can you tell me about speeding up innovation through NASA's Reimbursable Space Act agreement?
Well, NASA really is a national treasure in terms of knowledge and capability, and in some places, equipment. And we had a supply chain issue with some of our tanks, and we needed to get our test rig up and running. And we knew the Morpheus tanks were in surplus, and reached out to NASA, and they facilitated getting those tanks to us so that we could proceed with testing while our flight tanks were coming in.
And real quick, while you have you, why liquid methane, why liquid oxygen?
Well, in the near term, it's very easy to work with. It's environmentally friendly. It's non-toxic. It's very robust to changing conditions.
down the road, it's the exploration fuel of the solar system, and we can make it on Mars for bringing spacecraft back from there, so we don't have to take all the fuel with us.
Well, Tim, I know you're burning back to get back into mission control, watching your team that you fostered throughout all these years and listening to that IM-1 mission loop. We do appreciate your time today, and thanks for stopping in.
Thanks, Josh.
Awesome. All things great. And we are waiting. We are around T-minus 11 minutes, around 12 minutes, under 12 minutes from the launch. Things are looking great. All the vents, everything on the Falcon 9 are working as expected. And yes, it's kind of black, but it's because it's reused. And now, okay, let's listen in for the science payloads.
To figure out where you are in and around the moon. I'm holding in my hands the Lunar Node-1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat, and then to talk to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.
Now, IM-1 is the second launch of a lunar lander under NASA's Commercial Lunar
Hey,
Payload Services Initiative.
Greetings from Rochester, UK.
Pittsburgh-based Astrobotic.
Thank you so much.
The mission was
and
called
hopefully,
Peregrine Mission 1.
yes, this mission is not going to get.
But afterwards, Astrobotic reported a failure in its propulsion
this one.
system, which prevented the spacecraft from landing on the moon. 10 days later, Peregrine burned up after re-entering Earth's atmosphere. An anomaly review board will release its findings to what happened once complete.
And once I was also, I had this question whether let's say the Astrobotic had a failure, right? Whether those failure reports, it's not fully failure reports ready yet. It might not be ready yet, but initial conclusions might be ready, and whether they share those information with let's say this NOVA-C intuitive machines, because ultimately they are competitions, right? They are competition to each other, competitive people, and NASA. If you talk about lunar exploration as a whole, yes, in that case they need to share. But if you talk about private exploration and the businesses, then it's a business thing, a business. What is that term? Secret. And is confidential, you can't share it out. So how do you handle this situation? In that case, actually NASA interferes. I was listening to one of those interviews in which we had a similar situation, and there the person said that the NASA actually interferes in between. In this case is that they review the findings, whatever the company has, let's say the Peregrine, whatever they had, they'll review it, and accordingly they will suggest what all things can be made public, what all things cannot be made public, and then after that, after the suggestion, it will be in sole discretion of the company itself whether they want to share that information to other partners or not. So NASA does not kind of fully have the control over it. They can only give suggestions. But yeah, this is the case. So here also NASA suggested Peregrine to, share these findings with them. But I'm not sure whether this has happened or not. But if I have my company, if I have paid like millions of dollars for something to happen and I have found some edge case, would I be willing to share it with some other person, some other business competition, which can hamper my business in future? Something to think about, right? Yes, Chandrayaan landing is around 22-23 and it's all automated. So once it is in the lunar orbit, it will be around an hour or so. After that, automated landing sequence will come into picture and it will start landing automatically. It won't wait for a month or so to map the lunar surface or something. It will just land.
currently a go for an on-time liftoff. Next up, in just about a couple minutes, the structure next to the vehicle, known as the strong back, will begin to retract away from the vehicle. But while we wait for that, let's talk about what it takes to actually get to orbit. In order to get the rocket and payload into any orbit, the rocket not only has to go up really fast, but it also has to go sideways.
Engine chill has started.
As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, an image of firing a cannon from a really high mountain is what you can see there on your screen. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground.
RP1 load is complete.
This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example, and it provides enough power and horizontal velocity to the second stage carrying the spacecraft, enabling the spacecraft to be placed into orbit
Nice
around
animations.
the Earth. Now, you'll be able to see this today by watching the orientation of Falcon 9 after liftoff. The rocket will go straight up until about T plus 10 seconds, at which point we will begin that shift in orientation, gimbaling the engines so that Falcon 9 can go horizontally really fast. So be sure to look out for that after liftoff. Now again, at T minus 5 minutes and 38 seconds, all systems are currently go for liftoff. The strong back is going to begin retracting away shortly in preparation for that
T minus 5 minutes. You did not
clamp
miss.
arms, which are
Hopefully you
located
will
just
not
around the
miss
second
now.
stage, just below the fairing.
Actually, I have no doubts about the Falcon 9, to be honest. So it's a very reliable and good vehicle. So it will do the justice to, you know, put it into a proper translunar. I forgot about this. So this is not going like it's not following a Chandrayaan 3 part in which it will you know, move around the Earth couple of times and then finally go out to translunar injection. The Falcon 9 itself, since it is bigger, more powerful and has more capability, it will put it directly to translunar injection orbit, and because of that it will reduce the time by so much so that we are expecting a landing date of Feb 22-23. It's Feb 15. So if it had been launched yesterday, then also the landing date would be Feb 22. If it is launching tomorrow, then also landing date around Feb 22-23. This is how the orbital mechanics work. Everything would be adjusted by the rocket in that case, and then few adjustment by the spacecraft. So
and there you can see it on your screen. Those
nothing
clamp
will
arms
happen
are now
with
opening
methane
up
engine.
again.
Don't worry.
Once they are fully open,
I mean, yes.
that will allow the transport erector,
To be
that
honest,
structure next to
Peregrine lunar lander had issues with the fuel tanks. That too, they were not using cryofuels. So let's hope they are able to manage the cryofuels effectively in this one.
Should see that TE begin to move away, very slow and slight. But at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. And there you can see on your screen that TE is now moving away from Falcon 9. Falcon 9 uses two propellants, a refined form of kerosene called RP1 or rocket propellant 1 as a fuel, and LOX or liquid oxygen as an oxidizer. Now, fire generally needs three elements to ignite. That's heat, fuel, and an oxidizing agent, which is usually oxygen. This is what's known as the fire triangle. In our case, the liquid oxygen is chilled below its boiling point so that it has a much greater...
Stage 1 LOX load complete. It's going to happen. T minus 3 minutes left, guys. It's happening. It's going to the moon.
And in addition to these two propellants, we also use the chemical T-tab or triethyl aluminum and triethyl borane as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go, but it's the T-tab that sets the match to the propellant mix. And we did hear a call out that stage 1 liquid oxygen loading is complete. Coming up next, in the next couple of minutes at T minus 60 seconds, Falcon 9 will go into startup. That means that the rocket's autonomous flight computers will have taken over the launch countdown. And at just inside T-minus 2 seconds, we will light those Merlin 1D engines for liftoff. The Intuitive Machines payload continues to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. We are currently green for weather, and the range is ready to support a T0 of 1:05 a.m. Eastern Time.
And we are here, guys. Range is green.
And just waiting
Weather
for
is green.
the call out
Stage 2
for
LOX load is
liquid
complete.
oxygen.
Falcon 9 is green.
Right on time. Stage 2 liquid oxygen loading is now
Nova-C is
complete.
green.
That concludes propellant
What else is
loading
left?
on
Nothing.
the
It's going to
vehicle.
the moon now.
That means that Falcon 9 is fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Weather is 90% chance of
Ground gas closeout.
good weather for T0. And
It is
we
happening,
are
guys.
just about 30 seconds away from Falcon 9 going into startup. Now that propellant loading is complete, we are beginning to vent out the lines, the propellant lines on that transporter erector there, so you can see more of those white clouds around the vehicle. Startup is coming up here in a couple seconds.
Because
Falcon
in
9 is in
startup.
startup.
Great
That-
call out. That means that the internal flight computers have now taken over the launch countdown.
T minus
just waiting
1
the
minute
final
left,
go
guys.
from the
48
launch director.
seconds. It's happening.
LD,
It's going to the moon.
launch.
And
An excellent call.
there you go.
All systems are go for launch.
LD
of
has
Falcon
given
9
go
with
for the
Intuitive
launch.
Machines lunar payload.
T minus 30
30
seconds
seconds.
remaining. T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11,
T-minus
10,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and
and
liftoff.
liftoff.
Go SpaceX,
There you go.
IM-1 and the Odysseus lunar lander.
America to the moon again after 50 years. Look at that go.
Pitching downrange.
A small sun in the night sky.
Stage 1 propulsion is nominal.
Everything is fine. Don't worry about it. Everything is fine. It's normal. It will clear up. Max Q is the next step.
Has successfully lifted off from pad 39A at Kennedy Space Center, carrying the IM-1 payload. Now, during ascent, we tilt the engines, the technical term being gimbaling, and that turns the rocket horizontally. And
You can see it turning sideways. Max Q coming up. 7 kilometers already reached. And there
Mach
you
1.
go. The clouds. You won't see those cones here because obviously night. But Max Q call out is coming up very soon. And there you go. Max Q done.
Max Q.
You can see now the plume is expanding and it's actually going up the rocket, which is nominal because pressure
MX
difference
started.
Yep.
gradient is there.
We have a
Because
few
of
events
that it
coming up
climbs
in
up.
quick succession here. That will be MECO, stage separation, SES-1, and then the boost back burn startup on the first stage vehicle.
So now as
MECO,
you
or main engine cutoff, is where we shut down all 9 of those M1D engines on the first stage vehicle. That helps slow the vehicle down in preparation for stage separation, which is where the first and second stage will separate. And the first stage booster will begin its trip back to Earth. And the second stage vehicle will ignite that MVAC engine with SES-1, or second stage engine startup 1. And then the boost back burn will begin on the first stage vehicle, which is one of 3 burns that's required for the vehicle to make its way back to today's landing zone. And this burn assists with the vehicle to reorient
cutoff.
itself back towards land.
and there you go.
Stage separation confirmed.
Stage separation done and dusted. Oh, look at that night
Ignition.
sky. Wow.
Stage 1 boost back startup.
And we oh man, This looks amazing.
And there we saw and heard those call-outs for MECO, stage separation, SES-1, and the boost back burn startup on the first stage. Some great views there. Now, the first stage is currently performing its boost back burn. This is where we ignite a few of the engines to bring the trajectory towards the landing site. And coming up here shortly will be fairing separation.
Need plasma threaded. Yep.
Fairing separation confirmed.
Hey, there you go. Exposed to the space.
And an excellent view of fairing separation and an amazing view of the IM-1 payload attached to Falcon 9's second stage. Fairing deployment has been confirmed, and we will be attempting to retrieve these fairing halves once they fall back to Earth with our recovery vessel, Bob.
As you all know,
Both vehicles are on nominal
the
trajectory.
Falcon 9 first stage does not land on the
And
drone
some
ship
good
now.
call-outs there.
Boost back burn mostly
And
does
in
it.
about 3 minutes, there will be a couple more burns on our first stage to prepare for landing at landing zone 1 at Cape Canaveral. Again, we've completed the boost back burn on the first stage. That's the first burn of 3. The next burns coming up will be the entry burn and then the landing burn for the first stage vehicle.
140 kilometers.
Now we are at T plus 4 minutes and 17 seconds into today's mission. IM-1 is SpaceX's 14th launch this year, and the lunar lander on board could be the first U.S. moon landing since the Apollo program ended more than 50 years ago.
Excited for this, I hope.
You can see on your screen that the MVAC engine on the second stage is ignited, and we are currently in the first of 2 planned MVAC burns.
Follow the fate of Astrobotics Peregrine lander.
Screen, the first stage's entry burn coming up on that first stage vehicle. Again, that is the second of 3 burns. For the entry burn, we will relight 3 of those M1D engines, starting with the center E9 engine, followed shortly afterwards with the E1 and E5 engines. This helps slow the vehicle down as it enters back into the Earth's atmosphere. Now we need to slow down the vehicle to reduce re-entry forces, and that helps us to recover and reuse the first stage.
You can see the stage 1 telemetry is increasing. It's falling down because
again,
altitude, obviously. It will increase, then entry burn will start up,
you can follow the
then decrease,
speed and altitude,
then it hit the terminal velocity, and then finally landing
on the
burn.
left hand of your screen, that is showing the stage 1 telemetry and stage 2 telemetry on your right hand screen. And we are coming up on the entry burn for the first stage vehicle in just about 20 seconds or so. And what you're seeing on your screen on the left-hand side, it's a little dark there, but that is a view from the first stage. And with the entry burn, we should see that screen light up with the engines reignited.
It's coming up, and entry burn start. Hey, there you go. And now you'll see the speed is decreasing, all
and there you can see
because of the engines.
Burn has begun with those engines relit.
Stage 1 entry burn shut down.
So an entry burn basically makes sure that it does not hit that speed which actually breaks the rocket. You know, the plasma and all those things is not created.
Great call-outs, both vehicles on
and now it's decreasing, so you can see it's not increasing, decreasing. It has hit the atmosphere without even the burn happening right now. Terminal velocity will be achieved very soon.
Burn, that's just a center E9 engine burn, and that helps slow the vehicle down just in time for landing. That's coming up in just about 15 seconds or so.
It's decreasing, decreasing. You will see soon the landing burn will start up at around 3 kilometers or so. 2, okay. And landing burn started. There you go. Around 900 kilometers per hour is the terminal velocity.
On your left-hand screen, the landing burn has begun. Let's watch as Falcon 9. Let's watch as Falcon 9 touches down for landing.
It's always the bullseye. It's always the bullseye, no matter what. No matter what.
And a great view there.
Whoa, man. Yeah, thank you so much, Denizen, for coming up here. I will be here always, but you guys just come up here. That's what motivates me. Okay. Cool.
Nominal orbit insertion.
Yep,
And
never
just
loses
heard
its
Seco
crew.
1 as
And
well
now
as a
you can see the
confirmation of good
radiation.
orbit
It's Seco 1 has
for
happened. Now
our Falcon 9 second stage carrying our IM-1
the engine is
payload.
radiating that heat.
Now with that landing,
The lights are
that
on.
marks SpaceX's 273rd recovery
The lights
of
are
an
on.
orbital-class rocket.
Literally, they
including
have lights
first-stage
for this
landings
purpose
for
only, so
Falcon
that they
9
can
and
see the
Falcon Heavy.
rocket.
And with confirmation of good orbit, the mission isn't over yet. Coming up, we do have the second burn of our MVAC engine, or SES-2, on board the second stage around the T plus 41 minute mark, followed by spacecraft separation. So until then, we're going to send it over to Megan at KSC. Megan?
Thank you, Jesse. And if you're just joining us, welcome to the Space Coast of Florida, where we just witnessed live the liftoff of the moon-bound
Never loses its
spacecraft
cool.
at NOVA-C
It's always
Lunar
amazing,
called
and
Odysseus.
it's
And you know, we see a lot
always
of videos there, from Kennedy Space Center, but
mesmerizing to look at.
never gets old. So Odysseus launched on top of a SpaceX Falcon 9 rocket from Launch Pad 39A here at Kennedy Space Center. Intuitive Machines, an American company based in Houston, Texas, developed and built the lunar lander that is carrying, among other things, 6 NASA payloads. And if everything goes as planned, in 8 days, that NOVA-C lander is expected to land on the shadowy south side of the moon. Make sure you stay with us. Our broadcast here on NASA TV will continue through Odysseus's acquisition of signal, which is expected to happen around 1:55 a.m. Eastern Time. Now, before launch, we highlighted 3 of 6 NASA payloads on board the NOVA-C lander. The 4th is the SCALPS payload, which stands for Stereo Cameras for Lunar Plume Surface Studies. It includes 4 cameras at the base of the lunar lander. The images it captures will help scientists understand how landings impact the lunar surface for this mission and future ones.
SCALPS is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCALPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape of the ground. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
Let's head back now to Houston, where Josh Marshall is standing by live at Intuitive Machines headquarters with an update, and I'm sure very excited as well, Josh.
Thanks, Megan. With each passing minute, we are closer to receiving the lander's data in NOVA control. Right now, flight controllers are standing by for launch vehicle separation, followed by acquisition of signal. That's when the lander makes first communications contact, sending critical health and flight data into NOVA control. And we want to bring you closer to our Mission Operations Center to experience a few types of information that flight controllers are looking at during the mission. This particular screen is called the Deorbit Descent and Landing, or DDL screen. This screen is primarily used by the mission director and landing system experts. It's used primarily while NOVA-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side. The line is the tail where NOVA-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from NOVA-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration over time, with the ability to look back at what has happened. For some reason, flight controllers have lost data. Finally, The column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that NOVA-C's navigation system is in good health. That's because every measurement NOVA-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate NOVA-C to the lunar surface. It's no small feat, and the tireless effort of our entire Intuitive Machines team has brought us to this moment, standing by for launch vehicle separation and acquisition of signal in approximately 40 minutes. Until then, we'll toss back to Megan with more on the challenges that lie ahead of the IM-1 mission.
Yeah, we've been honest about it, you know, how difficult it is to get to the moon. We haven't done it in more than 50 years, but the CLPS initiative is going to change that. NASA and American companies who have teamed up to explore the moon know a lot of research needs to happen before astronauts head back to the lunar surface. In the end, the rewards outweigh the risks.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you'd have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLPS was to help establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier for a commercial environment.
But we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely?
They've been able to demonstrate that they have very, very good technical depth and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which
Hey, thank you so much, RF, for that 20. Really appreciate it, man. This would pay for my morning coffee. It's 12 here, so 12 p.m. here. Haven't had breakfast, so yeah, thank you so much for that. Really appreciate it. And because of you guys, this channel is still alive. So thank you so much. I hope you really like it, and I will keep on improving, so don't worry. So yep, right now we are in the coast phase. So if you this is okay, let's talk about this also. So this is a coast phase, which is around T plus 40 minutes it will again relight. Right now it is, you can see the velocity at around 26,000 kilometer per hour, and it's stagnant over there because the telemetry data is not coming. But what I meant to say was that the C code, I mean the SES2, second engine start 2, is necessary because it's going to the moon. It's going to elliptical orbit, and it's going for a TLI injection. Right now it's in the parking orbit around the Earth. Most probably, if that is not the case, yes, that is the case. 26,000 kilometers is more or less will this thing orbital velocity. So it's around the parking orbit around the Earth, so it is now waiting for that moment from where it will start firing, so that it can go for the TLI burn, TLI injection, and then it will separate the spacecraft. The spacecraft will do its own autonomous startup, and then finally the engine commission, the TCM maneuvers, and all those things will happen. So this is how it will work.
About a commercial lunar economy. That's kind of the end goal. So how does that
Cislunar
shape up the
economy.
clips? How do we get there?
A couple of different aspects. You know, when you hear us talk about wanting to form a lunar or a cislunar economy, in the short term, what that really means is encouraging the companies to get other non-NASA organizations to pay them to bring their experiments or their cargo on the moon. But it's actually a lot broader than that. Just by offering these contracts to industry and having them build their own missions that we can take a part of, the companies are developing their own, you would think of as a parts and high-tech ecosphere on Earth that's part of the lunar economy. Over the years, they've had to figure out ways to build these robotic landers. In some cases, helping other companies do new advanced high-tech components like rocket engines or fuel tanks or sensors, which didn't even exist 5 or 6 years ago. Of course, we can say now we're talking about small payloads going to the moon from commercials or having suppliers on Earth, but what the goal is in the long term is for these CLPS companies to be able to take to the moon work or goods or services of other bigger companies that just want to do work in space.
So what would you say is the agency's confidence in CLPS? You know, you laid out a very ambitious vision.
Yeah. Well, we think that the benefits of having this be successful, where we go out to companies and in effect we pay for a service to get our things to the moon, it's just so positive that we really are committed to exercising this model and seeing how American business does. Now, NASA is a learning organization, so at every attempt that the companies make, we're always looking at. We're trying to learn from that and figure out how we're going to adjust things to go forward to do next. But we're really committed to this public-private partnership and service model that we've embarked on.
Joel, thank you so much. I appreciate you being here.
Thank you.
Okay, so the fifth NASA technology we want to dive deeper into is called ROLSYS, which stands for Radio Wave Observations at the Lunar Surface of the Photoelectron Sheath. There's going to be a quiz on that later, so I hope you all took that down. ROLSYS will use 4 antennas and a low-frequency radio receiver system to determine how nearby radio emissions from the Sun, Earth, and other planets could interact or interfere with science conducted
okay, here
on the moon.
This mission is going to have 3 engine startup, not 2, 3. So I think first is we'll have to see the mission profile, how it is going up. But it's interesting that there are 3 burns for pushing it to the translunar injection. Thank you so much, RTF. Really appreciate it, man. Or
hey Megan, when I asked our mission directors about what should I expect from launch vehicle separation on until about AOS, and they said, well, we're just going to be patiently waiting. And after 4 years of hard work to get to this point, this must feel like an eternity. Let's take a live look into Nova Control. For some of the folks working today's launch and acquisition of signal shift, they've been working on the IM-1 mission
Look at
since
that
before
control
we were
center.
awarded the task order back in 2019.
USS Enterprise
Even
Bridge.
folks that started in the past couple years or the
Where's
past
the
few
captain
months
though?
have poured their hearts
As pointed
and
out by
minds into
Wildflower.
this IM-1 mission. In fact, every Thursday, Intuitive Machines holds a lunch and learn for folks to learn more about the company. And just a few days ago, one of our flight controllers, Brooklyn Herman, was describing today's events and said the opportunity to land on the moon has been a dream for her whole life. And everyone at Intuitive Machines is part of this beautiful mission, an incredible opportunity. And while we do have a moment just in between launch vehicle separation, we want folks at home to know that that same sentiment echoes through everyone at Intuitive Machines. We are humbled by the gravity of our mission, yet emboldened by the boundless possibilities that lie ahead, starting with acquisition of signal, which we expect to happen
He's
just
reading
a few
all that.
minutes after launch vehicle separation. For now, our team will continue to patiently wait and toss it back to Florida to introduce another IM-1 mission payload. Megan?
Well
Yep,
said, Josh.
he did all
Okay,
that.
so the sixth and final
It's okay
payload
though.
has 3
I'll do the
telescopes
same.
that will help the spacecraft
But
land
yeah.
safely. In the past, astronauts had to use a viewfinder or rely on radar.
So the Artemis program is taking NASA back to the moon, and everything
Yeah.
that goes
So
there.
in the Apollo era, they did not have this radar technology. So on the, if you have seen this web series, which one was it on Apple TV? It was a Foundation, or I wrote for all mankind. Yes, for all mankind. There they have demonstrated all these things. Basically, on the viewfinder itself, they had certain markings, and with the help of that, they were able to see. Basically, viewfinder is nothing but a glass window, and from there they were able to get to know the what is the relative distance between this and that. But that is not reliable at all. That is prone to human errors and everything. So after that, obviously LiDAR came in, and LiDAR is now being used and Chandrayaan 2 did not have this LiDAR information. It had some other radar, but not that one. Chandrayaan 3 had the laser radar, so that is LiDAR only, and obviously this one is also having a LiDAR. LiDAR is much more accurate and much more reliable than other radar methods. So yeah.
And the second is characterizing the surface of the lunar South Polar region, which is an extremely challenging environment to operate in, and it's preparing us for sending humans to the lunar surface in advance of the Artemis missions.
So very precise things they're being sent for to study. So, if they make it to the moon in 8 days, what happens next for each of them?
So even the payloads work starts even before they get to the moon. Intuitive machines, while it's transiting towards the moon, will turn on the NASA payloads to make sure that they survived launch and are operating as we expect. And then you've heard about the RFMG, the radio frequency mass gauge. It will be operating the entire time all the way to the moon and down to the surface to make sure that it's monitoring propellants and collecting the data that it needs to achieve its missions. And then during descent, you heard about NDL, the Navigation Doppler LiDAR, and SCALPS. They're going to be operating during descent and collecting their data. And then once on the moon, intuitive machines will turn on our other NASA payloads, and they'll take turns collecting data until they achieve their missions.
How are these instruments selected?
Early on in the CLPS initiative, NASA turned to our scientists at the NASA centers to identify science, payloads, and technologies that were relatively mature in their designs. We did that because we wanted the payloads to be ready for when the landers were ready to integrate them onto the landers and deliver them to the moon. So then NASA turned to the vendors and said, okay, you pick from this pre-selected list of NASA payloads which ones you think you can successfully integrate onto your landers and deliver to the moon. So Intuitive Machines actually chose the payloads that are on its delivery.
Deb, thank you so much. I can't wait to see what we discover with these payloads.
Me too. Thank you so much.
Thank you. Okay, so now we're going to step aside while we await our next big milestone, the second burn of the second stage of the Falcon 9 rocket, and then right after that, the separation of Intuitive Machines' lunar lander from that second stage. We are expecting that to happen about 20 minutes from now, so we will see you then.
And we are in the day side of the wait a second. Yeah, day side of the Earth. So yes, it's going to have SECO 2, SECO 3. It's not going to have a SECO 3. It's written over here. Okay. Third engine stage cutoff. In the website they wrote third stage engine cutoff, but it's not happening. So I think that is the first. That's what I expected also. The second burn to have only one burn we need to have, and then that should be fine. The translunar injection, it's already in highly elliptical orbit because you don't need around 26,000 kilometer per hour of velocity when you are in low Earth orbit. It's around 17,000 kilometer an hour, and that should be it. And it's very interesting, to be honest, because US they usually use miles per hour, right? But here they are using kilometers in hour. So that is something. But yeah, so right now it's in the coast phase. You will see it's not rotating because it does not want the ideally it should rotate, but it does not want the payload to have any those forces, rotational forces and all, because it's still having that payload in it. So it's not rotating stable, it's just coasting right now. And once it is near the SES2, second engine start 2, it will relight the engines and it will come to its full power, not full powers, a puff will be there, and then finally the translunar injection will happen and it will deploy. So let's talk about what happens after deployment. Okay, so in as I said, it will have autonomous deployment. Okay, what autonomous commissioning, autonomous deployment, whatever you want to say. Okay, so this thing is basically, what does that mean is that it will have do all the system checks, make sure it has its own battery power. So battery is also depleted in the because at the ground level it was being charged with the help of ground support equipments, but not when it's on the Falcon 9. Falcon 9 can charge, but I don't think so that happens for this one. So what happens is, let me tell you like the detailed detailed thing what will happen. So once the payload is deployed, the ODI, which is the spacecraft, will not know where it is. Okay, so it will not know where it is, but while after deployment it might some forces might induce some spin motion to it. So it might know where it is, but it can stop those spin motions, because obviously you can it's like person which is spinning in the chair with the closed eyes, it cannot know where it is orienting or whatnot, but it can stop its chair. It's like that. So once the spin is stopped, then it will open the cameras for the star trackers, which will there are 2-3 star trackers which will be there, which will open up and see where the stars which it wants to track is. Once it is able to match the images of the distant star, it will know where it is oriented and where it is going. Okay, so after that, the software on board takes the star tracker measurement and process them through the algorithm which is known as the Kalman filter. Okay, which is used to correct the onboard orientation, which is nothing but it's just calibrating. The star trackers is calibrating its instrument, as well as making sure the spacecraft is in right orientation. Once the GNC system has autonomously determined its attitude relative to the star, then it uses a reference position from the nominal launch vector to determine the appropriate location of the sun. So it's not looking at the sun directly right now, it's looking at the stars. Once it is okay, the stars are there, stars are it can look at the sun, but it's looking at the stars, because stars are also what I mean by star is literally stars. Those stars which are there in the sky, those are stationary relative to the motion of the spacecraft, because they are very, very far away, and those stars do not our velocity has a very little, very, very negligible effect on the position, so we can choose those as a reference point. So it will try to find the location of the suns. GSE then commands the RCS jets to maneuver the lander's top deck, which is having the the sun, the solar panel, as I said. Basically it's trying to move on to the sun pointing mode. So it will the lander's top deck will be towards the sun, with the slight angle to illuminate the top deck and the side solar arrays to generate maximum power. So this is not exactly at the sun pointing mode, but it's at the slight angle in which the upper panels as well as the side panels are illuminated. I think this is they are doing for the communication part, because it is at the sun pointing mode, then it won't be able to properly communicate with the Earth. So that is the thing. So after that, Audi holds this approximate attitude within plus minus 50 degrees for the entire mission, other than when flight controllers in NOVA Control Center want the high gain antenna to be pointed towards the Earth. So that is the thing. And in the meanwhile, all those things, they will be the flight controllers at Texas will be managing the lander's thermal state on the vehicle by keeping other systems in the shade of the top deck. As I said, this is why it is important to have a maximum solar input from the top deck, because it is using the cryo fuels. And this is, okay, let me finish this thing. So when autonomous commissioning is complete and the max power is established, ODC turns on its communication radios and makes first contacts with the flight controllers in the NOVA control. So this is how it works. So it will not, there might be some heartbeat things which might be going in, but it will not know this all things will have to come into picture first. After that, it will autonomously point its antenna towards the Earth and then send the signal basically. So this is how the whole process would look like. First, stop the spin rate. Next, open the star trackers. Third, point towards the sun. Fourth, hold that position for certain time, and then finally point your antennas towards the Earth and send the signal that you are good and healthy. After that, it will be on the flight controllers to do what they want to do with the spacecraft, and yeah, things will look like that. So talking about the thermal control, there is kind of very interesting thing. Once it is in the lunar orbit, there is one reason why it is not orbiting the lunar orbit for a longer period of time, and the reason is actually the cryofuels. So since cryofuels are cryogenic, it has its own temperature, negative degrees Celsius, minus 200, minus 180s and all those things. So basically there is always a risk of them boiling off if you stay on the orbit for a longer period of time. First reason, okay, because no matter how you try to manage it, there will be certain times because where if you stay in for a longer period of time, you won't be able to manage the proper thermals, and it will boil off. For sure it will boil off. So you don't want that. You want your fuel to be optimal for the landing time. So first reason is that. Second reason, it is getting the beating from the sun as well as it is getting the beating from the moon once it is in the lunar orbit, because there is something called albedo, which is nothing but the lunar as you know, right, the moon which we see in our night sky, it's shining, it's illuminated. It's not because it has its own light, but because sun is hitting on it and it's reflecting back. So basically it has energy. That is what is happening. So once it is in the lunar orbit, not only it has to take the beating from the sun, but it also has to control the beating from the moon, which is the rays which has hit the moon and is coming back from the moon and then hitting the spacecraft. So it has to control that also. So it can do that for a limited period of time. This is the reason why just after entering into the lunar orbit, in an hour or so, that's it. After doing all the checks, it will go and start the lunar descent maneuver. It's all part of cryofuels handling, right? And yeah, this is how it will look like. But before that, now SES2 is coming up, so we'll see that. But yeah, I hope you like this information, and I really have high hopes that this mission will be successful, because the way they have made this lander, they have not rushed it up. 2013 the company was established. They had NASA and all those people as consultations, and I really feel that this is the one which will make it. Also, although they are aiming for a very notorious location, which is kind of very difficult to land on. We already knew what happened with Chandrayaan 2, so it's not flat at all. It's very difficult, and hopefully all those instruments which NASA has provided for this very purpose will be useful for it to guide it to land on a place where there are no boulders. So let's hope, let's see what happens, and hope for the best. Now at T plus 44 minutes, the SES-2 will start, and after a small puff, the translunar injection will be completed. And yep, let's see. Yes, Owens, that is the thing. After half a century, the people are America is returning back to the moon. Although this would have not been possible if China wouldn't have risen to the occasion. The reason US is interested now on the moon is because China is interested on the moon. It's like previously they went to the moon because of the USSR. Now they're going to the moon because of the China. And I really hope this does not end like what happened with the USSR, you know, just because US won the space race, the lunar exploration died. Although we now have a good intention to go. It's not just about winning the race. We have water over there. So yeah.
Currently awaiting the second burn of the Falcon 9 second stage and separation of Intuitive Machines' lander. This comes after a successful liftoff of the Falcon 9 rocket with the NOVA-C lander called Odysseus at 1:05 a.m. Eastern Time. Intuitive Machines, an American company based in Houston, Texas, developed and built the lunar lander that is carrying, among other things, 6 NASA instruments. And if everything goes as planned, in 8 days, mark your calendars, February 22nd, that NOVA-C lander is expected to land on the south side of the moon. Let's go now to SpaceX headquarters in Hawthorne, California, where Jesse Anderson is live as we await that second burn and then spacecraft separation. Jesse.
RCS is burning up, making sure it's in the right orientation.
Now we are about a minute and a half away.
Look at that crystallization of the RCS.
Of engine. Next coming up will be SES-2, that second stage engine start 2, and that
Look
will be
at
followed
that! Wow.
by SECO-2, which is second stage engine cutoff. This burn will last about 53 seconds and will help the vehicle to make it to its final targeted drop-off orbit. Then the vehicle will coast for a few minutes prior to spacecraft separation. So we're getting very close, and this is getting very exciting here. Again, we're just about a minute away, just under a minute away from that last burn of this MVAC engine here.
Wow. Yes, Space Race 2 is happening, but it's happening for a good reason.
Now, right now, what you're seeing on your screen
and hopefully it will continue.
An excellent view
because if it would have continued at that time, USSR and all, if Russia would have won, right, it would have continued and we would be far ahead, far ahead in all aspects, not only in space exploration, but in all aspects of life. That is demonstrated by For All Mankind. You can watch out that series. It's on Apple TV. It's amazing.
15 seconds or so. And hoping to be able to continue these live views here so that we can see SES-1 and SECO-2.
And we have ignition. It will go on for certain time, for few seconds, few minutes. You can see the velocity is increasing so fastly, so hastily, right? Because it's
there you can see we have just had SES-1. You can see that MVAC engine has now relit. Again, this is just about a 53
You can feel the velocity now,
just
right?
Under a minute.
With the earth and the vibrations. 33,000 kilometers per hour. 34.
And shutdown of
Translunar
this
injection
MVAC
is coming
engine
up.
coming up here in just about 10 seconds or so.
And 36. Seco is coming up now. You can see the nozzle actually, you know, vibrating. And we have cut off. 37,000 kilometers per hour is the translunar injection
And there you
velocity
can
that
see
you
Nominal
need.
orbit insertion.
And we have a nominal orbit insertion. There you
The
go.
MVAC engine has shut down, and we did hear that call out for a confirmation of good orbit. So with confirmation of a good orbit, it looks like we are on track for spacecraft separation in just a few minutes from now, just about a little over 5 minutes. Now, it's been a great launch so far. SpaceX did begin fueling of the IM-1 lander on the pad about 2 hours and 20 minutes before liftoff. And we did talk about that a little bit earlier in the webcast. It's a totally new procedure and new hardware for SpaceX that enabled fueling of the IM-1 lander on the pad with cryogenic methane and oxygen. Now, to be able to do that, SpaceX teams modified Launch Complex 39A's pad and transporter erector, installing a new liquid oxygen tank, a methane tank, propellant lines, and 2 control skids on the transporter erector. Then from there, the new propellant lines pass through a new stage 2 quick disconnect that attaches to new plumbing and another set of quick disconnects that lead to the IM-1 lander. And given the lack of methane used on the Falcon program, Falcon teams actually leaned on the expertise of Starship teams and used methane sensors from Starship to verify the health and status of the lander for our
Look at
fueling
that,
system.
you know, helping hand. Starship's methane sensors were
Now,
used
if you're
to
just now joining us, we are just
make
about
sure the
4
propellant
minutes
levels were
away.
fine
We're
on the
awaiting spacecraft separation
lander.
of the IM-1 lunar lander, which is still currently attached to Falcon 9's second stage. And we did just a couple of minutes ago had a good last and final burn of our MVAC engine.
So you might be
SES-2 and
wondering why
SECO-2.
did not deploy at the, you know, just after the burn was completed. It can technically deploy that, but right now you can see the telemetry is not ideal, right? So it wants to deploy at a position where it's in the visibility of the ground station so that it can monitor. So that is the reason why we are waiting for certain time. Once it goes to that location, it's in the range, it will deploy and it will things will happen. So mostly when it takes some time for it to deploy, mostly it is because of the ground station visibility. And sometimes it's because there are certain system checks which it needs to do before deploying the payload itself. It's doing that, and after that it is deployed.
For those of you following along, this booster has supported GPS 3, Mission 3, Turksat 5A,
Yep, over Aussie.
Transporter 2, Intelsat G-33 and G-34, Transporter 6.
Yeah, that's what. It's going over Aussie, and after that it will deploy because it will have visibility over there.
At about T plus 7 minutes and 46 seconds, we did have a successful second engine cutoff for SECO-1. That was the first burn of the 2 burns for this mission. That was followed by a confirmation of good orbital insertion. The vehicle was then able to coast for a bit there, and then again, just a few minutes ago, we did have the second burn for this MVAC engine. 2 burns required to reach the targeted drop-off orbit for this IM-1 lander. And now the vehicle is coasting with payload attached, and we are just a couple of minutes away from spacecraft separation. IM-1 could become the first U.S. lunar lander since Apollo's last landing in 1972, almost 50 years ago, and could be the first commercial lander to succeed in reaching the moon's surface.
Yep, space race
Again,
all over again.
A minute and a half, just under a minute and a half away from spacecraft separation. And on your screen, as we wait to get some live views, you can see on your bottom right-hand screen.
You can actually they have done a good job of making the tracking down on the Earth also, so you can see where it is actually above on the
and there's
Earth.
that live view there. Again, this is a view
It's
From
52
the second
years,
stage vehicle,
literally.
looking aft at our
One whole lifetime of a person. So a person who is born in 1972 who has missed all the action, right? Kind of. Because at the time when the Apollo mission, the future Apollo missions also happened, it did not, the person who was born in 1972 would be a child, so would not have understood much. And after that, now it is happening when he or she is old. So, hey, look at that view.
Perfect timing. We've got this great live view of the IM-1 lander right before it begins its 8-day journey to the moon.
We will see the deployment happening very soon.
An incredible view and very exciting that we have spacecraft separation coming up here in just a few seconds.
Come on, deploy. Hey, deployment successful. Look at that go. Wow. That heat shield is also amazing. You can see the heat shield literally over here. Wow. Just look at that star formation. This is so cool.
IM-1 NOVA-C Lunar lander drifting away from Falcon 9's second stage, confirming spacecraft separation. From all of us here at SpaceX, we are wishing the IM-1 lander a great flight and safe travels. SpaceX is honored to be a part of NASA's Commercial Lunar Payload Services initiative to deliver science and technology to the lunar surface, and we thank NASA and Intuitive Machines for entrusting us with today's historic mission to the moon. For those of you following along, you'll know that this mission marks our 14th of the year and second just today. Congrats to the SpaceX team. We're just in February and we've already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE. And we're gearing up for the Crew 8 mission before the end of the month. Check out spacex.com/launches for up-to-date missions and schedules. And before we sign off, let's go back to Josh at Intuitive Machines. Josh?
Yep, it's cool. It's very, very cool.
What an incredible, incredible view. Just a few moments ago, our flight controllers inside of Nova Control heard that confirmation of launch vehicle separation. This starts the countdown toward our lunar lander's autonomous commissioning. During this milestone, the lander is going through the steps required to power on, determine its position relative to the sun, and make communications contact with flight controllers in Nova Control. It's an autonomous process that takes several minutes. In that time, we'll walk you through what's happening in space approximately 223 kilometers or 139 miles from Earth. At launch vehicle separation, a spring force gently pushes NOVA-C away from the launch vehicle's second stage. We just saw that, allowing the lander to deploy and drift away toward the moon. Brake wires connected to the launch vehicle let the lander know it has deployed, and NOVA-C starts an internal timer to count down to when it's safe to turn on. After the timer finishes, NOVA-C's primary systems are expected to autonomously power on. This includes guidance, navigation, and control, or GNC for short, automated flight management software, radios, sensors, and thermal control. The GNC system powers on the cold gas helium reaction control system to stabilize the vehicle's attitude, because at this point, the lander does not know where it's pointed, but it can stop any residual spin motion. This is much like a person spinning in a chair with closed eyes can stop spinning without knowing which way they're pointing when they stop. After controlling the spin rate, special cameras known as star trackers autonomously match images of the distant star field and provide NOVA-C with its orientation. Software then takes those star tracker measurements and processes them through an algorithm known as the Kalman filter to correct the onboard orientation. The lander now has two critical data points: its attitude relative to the star field and a reference position from the estimated launch vector. With these data points, NOVA-C may command its reaction control system to maneuver the lander's top deck solar array toward the sun for illumination, generating maximum power. All of these steps are expected to be happening right now, and when autonomous commissioning is complete, our NOVA-C lander named Odysseus turns on its communication radios and makes first communications contact known as acquisition of signal, or AOS. Making that communications connection involves more than the lander's operations in space. It takes careful coordination here on Earth too, using Intuitive Machines' Lunar Data Network. The network was designed to support NASA's CLPS initiative, government services, and other commercial efforts using line-of-sight and data relay services for spacecraft in cislunar space, which also includes low Earth orbit. The secure network is made up of NOVA Control, which we're keeping our eyes on right now, and strategically placed ground stations spread across the globe. The ground stations are expected to provide near continuous communications with NOVA-C during the entire IM-1 mission. With that entire network available, our flight controllers responsible for communications and ground stations will be the first people in NOVA Control to start seeing data from our lunar lander, which means the ground station assigned to this part of the mission has locked onto Odysseus's signal. Now, from the lander to NOVA Control, all of these innovations and capabilities are being put to the test right now as we prepare to enter our nominal acquisition of signal window with NOVA-C. Right now, we are listening into the mission audio loop and looking live into NOVA Control.
SpaceX just deliver us the OPM file.
Okay, copy. You're good to process in the background while we work contact.
Okay, I'll work with Fido on this.
You will get the signal. I don't
Right
think
now,
so that
we
would be a
estimate
problem.
that the lunar lander is traveling about 10 kilometers per second, which is about 24,600
All right, I want to make sure
miles
Com's
per hour.
happy with it. Com?
Standing by. I don't see packets updating in packet counts unless I'm looking in the wrong spot. And I'm not seeing anything populate in AOS.
So we're still standing by for autonomous commissioning and making that first ground communications from the lunar lander in space.
Waiting for the acquisition
We
of
expect
signal,
the
guys.
carrier lock call to come from the COM or ground network stations inside of NOVA Control. And this is Houston's first commanded lunar mission since Apollo 17.
All right, I see packets. And
Yes.
All right,
There
guys.
you go, guys. Acquisition of signal
And
confirmed.
there we have it. We have packets. That is Michaela
think
Landivar.
All right,
That
guys.
guy is the
Com,
captain
I
of
want
the
your
ship.
Report. Uplink and downlink, what do we got?
Okay, so I am seeing packets populate on the AOS screen and in the packet counts area. Looks like telemetry is coming in pretty well. We have not started uplink, so we do not have uplink locks at this point. But it looks like we are seeing most everything that we would expect as far as
That's an
downlink is
excellent
concerned.
call. We have reached
It
a
is
pivotal
one thing that I
milestone.
need to
We're going to
look
bring it
into
back
potentially.
into the broadcast booth and congratulate the team working inside of NOVA Control as our NOVA-C Lunar Lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with NOVA Control. What an achievement for the entire Intuitive Machines team. Let's honor this momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey. From Intuitive Machines' NOVA Control in Houston, Texas, thank you for joining our portion of the IM-1 mission broadcast. We'll toss it back over to Megan in Florida for reaction to this successful launch of our IM mission. Megan.
Amazing,
from here,
amazing,
NASA, we just
amazing.
wanna say congrats
Okay,
to
guys,
John.
I think that should be it from my side also. And hopefully we will see this mission hopefully makes it to the moon, and US becomes again the country to land on the lunar land on the moon or the lunar south pole. So we'll see more progress over it on now on the Feb 22. It's supposed to enter the lunar orbit and do the, as I said, it won't stay there for long, and I have said the reasons also why. So it will start the landing on Feb 22, mostly Feb 22, or it might go to Feb 23. We don't have a proper landing profile as of now, how it would look like, but I think they will give us. And yes, we will be having the live stream for that, and I will be live streaming it, so don't worry about it. What about the slim roll? Oh yeah, so I forgot about it. So it is so about the slim roll. Yes, it had some orientation issue, and because of that, it lost its battery for some period of time. But fortunately, once the solar panels were aligned in the right direction, it was able to regain power and do the experiment. So yes, Japan's landing, as it Japan's mission profile, as cartoonish it was, the landing was also cartoonish, but at the end of the day, like Kerbal's, cartoonish, what I mean by cartoonish is by Kerbal landing. It was literally a Kerbal landing, Kerbal mission profile and Kerbal components. And finally, in KSP, even though you the ship is like this on the surface of the moon, you are landed on the moon safely, and with the help of some tweaks, and here you just move your spacecraft up and then it goes up. So kind of that. So Slim was able to do everything which it was supposed to do. So yeah, kudos to them, W Japan. And I am now hoping that this mission is also successful. All my bets on it. So
ignition and liftoff. Go SpaceX, go IM-1 and the Odysseus Lunar Lander.
Alrighty. Okay guys, thank you so much for tuning in. Now the next mission would be on 17th. There is 2 missions coming up. That would be a interesting day for me, because the 2 missions coming up, GSLV Mark II launching, as well as H3 launching for the second test flight. So that's Japan's H3 is launching. After that, after 17, there will be 22nd will be coming up in which this Nova lander will be landing. So thank you so much for tuning in. I hope you liked the stream, and I hope you were able to grasp what I was trying to say. Try to simplify it, but I may not be able to simplify it that much. But yeah, you just come here, enjoy, sit back, relax, and I try to make sure you are happy, you are satisfied at the end of the day. If you felt like that, please hit that like button, subscribe, and I will see you next time on this channel on 17th of Feb mostly for 2 times. Let's see. Thank you for joining in. This is Priyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.